Hi, this is Tom, and this is the second video for lesson 33. And what we're going to do now is we're actually going to calculate correlation. And so let's come down here, and what we're going to do is, I'm going to use my pencil, is first give you the value of R. So here's what it is. It's a big formula. It looks like this. It says R is equal to N times the sum of the xy's minus the sum of the x's times the sum of the y's. And now it's going to be divided by, and it's this big division problem. It looks like this. It is the square root of, and we have a whole bunch under there, so bear with me. It's n times the sum of the x's squared minus parenthesis the sum of the x's squared parenthesis times n times the sum of the y's squared minus parenthesis the sum of the y's squared. There. That is a big formula, and I agree, but it's not as bad as it might look. For example, we've seen this symbol. This just means sum, or add them all. And we know what x's are and the y's are, and we have a couple n's in this. There's an n there, here. And n is just the number, in this case, it's the number of ordered pairs. Number of ordered pairs. Now, there's something, the number of ordered pairs. So what we're going to do is we're going to use this formula, and we're going to find the correlation for, our loan data. So let's put that back in here. And I'm going to bring it right over there. Okay. Then, here we go. Now, when you're calculating R, I think the easiest way to do this is to just make a table. So notice that all these green values, these are my ordered pairs. So we'll start at the first one with 1. And we're going to make a table that has this. It has x's, have y's, you'll have xy, x's squared, and y's squared. That's all we need. And actually, I'm going to just scoot it over a little bit. Like that. And we're going to extend it over here, and we'll put our ordered pair here. Ordered pair. So our ordered pairs. Our first one we have is 100, comma 1. And our second one is 85, comma 2. Our next one is 69, comma 3. Okay, our next one is 51, comma 4. And then our next one is 31, comma 5. And our last one is 9, comma 6. So that's our table. We're going to fill it in together here. And here's what it is. Remember, an ordered pair is always in the pattern of x and then y. So the very first one that says here in x's, you write down your x. Well, my x is 100. For my next one, my x is the 85. My next one, it's a 69. Then a 51. Then a 31. And then a 9. And then we write the y's. Well, the first y is a 1, then a 2, then a 3, then a 4, then a 5, and then a 6. Okay, now we're going to come back to that formula in a little bit. Now it says we need to take x and multiply it by y. So for this first one, we would take the 100, multiply it by the 1, and we'd get 100. On the second one, we would take the 85, multiply it by 2, and come up with 170. So if we keep doing this, we're going to come up with 207 for 69 times 3. 51 times 4 is 204. 31 times 5 is 155, and 9 times 6 is 54. All right, let's keep going now. We're going to keep on going. Then we have our x squared. So in the first one, 100 is the x. We square it to get 10,000. So that's going to be 100 squared is 10,000. Then 85 squared is 7,225. And I know these are some big numbers, but we can deal with this. The next one is 69 squared, which is 4,761. And the next one is 51 squared. That's 2,601. Then our next one is the 31 squared. That's 961. And our last one is the 9 squared, which is 81. And by the way, I'm actually not doing these all immediately. I have done this ahead of time. But what I would encourage you to do is at the end of filling in the table, that stop and double check yourself using your calculator and making sure you get the same numbers. So now we take the y's and square them. So for the first one, we take the 1 and we square it to get 1. The second one, we take the 2 and we square that to get a 4. Then we take the 3 and we square it for a 9. The 4 and we square it for 16. The 5 we square for 25. The 6 we square for 36. Now, look at the formula up above. Notice what we have here. We have right here in our first space, we have an xy, and here's our xy. We have an x, there's x's, y's, there's y's. Here's the x's squared, and we also have y's squared. So this table has everything we need, and all we need to do is our last bit. Because notice that every single thing, every one of these x's and y's, x squareds, y squareds, and x y's, they're always the sum of those. So what we do is we make one last row in our table where we just take the sums. So if we add up all of the x's, we come up with 345. If we add all the y's, we get 21. If we add up all the xy's, we come up with 890. If we add up the x squareds, we get 25,629. And if we add all the y squareds, we come up with 91. And now we have what we need. So let's take these and plug these into this formula right up there. So let's take our formula. I'm going to bring it back down so we can maybe see as we go. Take a copy of that. Let's put it right down there. And here we go. All right, so we take n. N is the number of ordered pairs, and we have 6 of those, times the sum of the xy's. So the sum of the xy's, that is the 890. Minus, you know what I'm going to do here for a moment is let's take our table and shrink it down. I think that'll make it so I can fit more on our screen and we can see better. There. So now the sum of the, actually let's do this. I'll move it all the way over to here even. There we go. So now the sum of the x's, well, that's the 345. The sum of the y's is 21. And then we put all of this into the square root. So we have this big, huge square root. So we take n, again that's 6. We take the sum of the x's squared. That is 25,629. And that's in parentheses. Minus, parenthesis, the sum of the x's. Well, that's 345. Square that, and you need another parenthesis. Then we need a left parenthesis. N is 6 again. The sum of the y squareds is the 91. Minus the sum of the y's. Well, they add up to 21. We need to square that, and then we need a parenthesis. Now, when you put this in your calculator, I would encourage you to do it in 2 parts. First, put exactly what's written in the numerator into your calculator and record that number. And if you do that, you should come up with a negative 1,905 over the next number. If you type exact in the numerator, not the square root, but just what's inside the square root, put this in calculator. So now if you do, what you're going to find is that this simplifies to the square root of, it's a big number, it's 3,648,645. Now, you might be thinking there's no way that's going to come in between 1 or a negative 1. But now I would put this into my calculator exactly like this. I would type your negative symbol, type 1905, type your divided by, which will actually give you the forward slash. Then you're going to hit your square root button and type in the 3, 6, 4, 8, 6, 4, 5, and then you're going to arrow your cursor out of the square root and press enter. And when you do that, you will come up with negative 0.997. Whoa, that's very, very close to negative 1. And so what we can say is that the loan data, the time and principal, has a very strong linear correlation. All right, we're going to do one more example, but this video is running probably long enough. So I will see you in the next video for one more correlation calculation. Thanks for watching, and see you then.